Pinpoint Weather University, sponsored by Gaston Roofing.
Welcome into Pinpoint Weather University. I am meteorologist Brandon Lawson here on Queen City News Plus. Hopefully you've had a great week so far, and we are launching into this episode with a lot of tropical information. Hurricane season really picked up here over the last week or so. Really, as we ended the month of September, we really saw a big increase in tropical systems. And it was also an increase in work for us here in the Pinpoint Weather Center because it was a hard forecast. We had Imelda and Humberto in the Atlantic. They both formed, got really close to one another, and it made the forecast extremely challenging for us and for all meteorologists, including National Weather Service and National Hurricane Center folks. They had a hard time with this forecast as well. I'm going to talk about why in this episode. We're also going to talk about some of the lack of data that we have in the Atlantic that does make tropical forecasting as hard as it can be sometimes. So we're going to discuss why the Imelda and Humberto forecast changed so much over the course of like 5 or 6 days, why there were drastic differences in rainfall totals leading up to this storm, and why it ended up turning out to be really nothing but scattered showers for us here in the Queen City News viewing area, and why the coast still saw some of those impacts with swells and rip currents. So we'll get into all that in just a moment. But first, as of recording this on Wednesday, October 1st, we are now in a partial government shutdown. And the reason I want to bring that up is because with weather, obviously, we've got government agencies that control a lot of forecasting. That includes the National Weather Service, the National Hurricane Center, really everything under the umbrella of the National Oceanic and Atmospheric Administration could have some impacts with this. Now, I want to show you what that did in the 2019 partial government shutdown to things like the National Weather Service. So during the 2019 partial government shutdown, what stayed operational? The essential weather forecast stayed in action, right? They were still, National Weather Service, they were still putting out forecasts. National Hurricane Center was still tracking hurricanes. That did not change. We had radar monitoring. We got those life-saving weather alerts during the partial shutdown in 2019. That happened during the winter, too. So you've got winter storm watches and warnings and different alerts that were being issued during that time with blizzards and different things like that. And as we went into 2018 to 2019, because again, this started in December of 2018 and then went to January 2019. It was a 35-day partial government shutdown. And again, forecasting, weather alerts, and even tracking the radar, hurricane tracking. They even, obviously this happened in the winter, but if it was to happen during the summer, at least in 2019 or 2018, it seems like they would have also had that as one of the essential products that would have continued. So 2018 partial government shutdown, that's what stayed in action, right? So now let's go into what was suspended during the 2019 partial government shutdown for NOAA and the National Weather Service offices. Outreach programs, public events, also non-essential website things. So essentially, this is like your storm spotter training, your workshops, like the meetings they have with emergency managers, and also like, let's say they were going to go to schools, different things like that. Climate research was kind of halted during that partial shutdown. But I will say, as of this morning, again, Wednesday, October 1st, I did reach out to our local National Weather Service office friends at the Greenville-Spartanburg National Weather Service, and they tell me from guidance they've received, operations will operate as normal. So operations as normal with the current partial government shutdown. Now, that can change. I was told that could certainly change, but right now, NOAA, let's see, and especially the National Weather Service, National Hurricane Center, things like that, are going to continue operations as normal. And that's good news because they're very important, especially during this time of year. We're getting ready to go into severe weather season. We're still in hurricane season, still have some activity that can get going there in the months of October and November. So definitely need all of them to be on deck. This includes the Weather Prediction Center, Climate Prediction Center, everything that they can use, like resources and workshops and things like that, make them better as well. And they make us better too, because it makes it easier for us to communicate with them. So that's just a look at how the partial government shutdown has impacted NOAA in the past and how it could maybe impact things in the future, at least with this partial government shutdown, depending on how long it goes. But for right now, I'm being told that operations as normal, at least at the National Weather Service, with the current partial government shutdown. With that being said, I want to get into forecasting, and I want to start this episode off with the tropics. I want to talk about the Fujiwara effect. Now, you've probably heard this word thrown around a lot here recently because it was a phenomenon that occurred recently in the Atlantic between Hurricane Humberto and also Hurricane Imelda. So the Fujiwara effect was created in 1921 by a Japanese meteorologist. His last name was Fujiwara. That's why the name, hence the name Fujiwara effect. Now, it's a rare phenomenon between two tropical systems. I like to think of it as the storm dance. The two storms are dancing together out in the Atlantic. They're swinging their hips. They're moving around a little bit out there in the Atlantic Ocean. They're doing that together. So that's essentially what happens when two tropical systems get close together and they start to move around together a little bit. Now, obviously, I'm not going to leave you hanging. Let's get you a graphic to show you kind of what that looks like. So the Fujiwara effect, what is it? And I'm kind of using an example from essentially what we just saw out in the Atlantic Basin. So the Fujiwara effect, again, it happens when tropical systems get within at least 870 miles of one another, or it can occur if they get that close to one another. Scenario one of the Fujiwara effect, there's a few different scenarios that can happen, but scenario one is that the two tropical systems can rotate around a common axis. So essentially, they circle around each other. That is one part of the Fujiwara effect. Now, scenario two, let's put them back to where they were here. Scenario two, the cyclones can merge into a single storm. Now, I want to caution you, there was a lot of information on social media about Imelda and Humberto merging into this monster storm, and that just wasn't the case. And it's not always the case with these systems. We're actually kind of seeing that here this morning on Wednesday, October 1st. We're kind of seeing Imelda and Humberto kind of merge together a little bit. I'll show you that here momentarily. But the cyclones can merge into a single storm. What can happen with this is, one storm is much stronger than the other, and it just kind of absorbs the energy of that storm. So it doesn't necessarily get incredibly stronger, and it's not like two Cat 3 hurricanes smashing together and they become a Cat 5. It doesn't work that way. It's just the cyclones kind of merging together into a single storm. Now, it can get bigger and stronger off of it, but just in case we have this scenario in the future, if things pop up on social media that they're going to merge into this massive hurricane. Unfortunately, we don't have Cat 6 hurricanes. And unfortunately, on social media, I saw a lot of people sharing that Imelda and Humberto was going to merge into this Category 6 storm. And it's just not the case, man. It frustrates me. I love to be excited about weather and jumpy about it, but it just so frustrates me when you see fake information like that and there's so many shares with it because it's just a lot of misinformation. And obviously, that didn't happen in this case, too. So that's just something to keep in mind for maybe future storms that do get close together. Now let's talk about scenario three. The storms can repel one another, kind of push each other away, fight. They're like, nah, I need to get away from you. So scenario three, that's kind of how the cyclones can repel each other. Now, I got to get you the real world example. I got to show you the example of Imelda and Humberto and how this actually happened just recently. So Imelda, Humberto, we've been talking about that storm for seems like a week or two now, those two storms, and they got close together. That's what really made the forecast challenging. Whenever you have the Fujiwara effect, it makes the forecast very challenging because these storms can kind of make erratic movements, and the models have a hard time picking up on that, especially long range. Coming up in the next segment, we'll be talking kind of about how tropical forecasting can be difficult long range, and also why you might have seen, unfortunately, some meteorologists kind of irresponsibly posting 12 to 15 inch model data well before a storm even formed. We're gonna discuss that too. We're gonna talk about why tropical forecasting long range can shift and be changing at a moment's notice when it comes down to model run. So we'll talk about that momentarily. First, let me show you kind of the real world example of what we saw with this system. So what happened here? So we've got our storm pulled up here. We've got Hurricane Humberto on the eastern side, and so it's the eastmost storm. And then we've got Hurricane Imelda, the westmost storm. It's the one that's closest to the coast here. So notice how these two storms, I'm playing this very slowly, but look at how they're rotating around one another. So you can kind of see they're trying to rotate around that common axis. And both of these storms during this Fujiwara effect were essentially almost the same strength. Now, Humberto was much stronger to start, so Humberto kind of helped pull Imelda out to sea. It was kind of the forceful storm. But again, we're playing this through Tuesday, still kind of rotating around each other. Now, I want to skip forward a little bit. Notice how they kind of start rotating around each other and how Imelda or Humberto falls apart to the east, northeast there. And Imelda is actually kind of absorbing a little bit of what's left of Humberto. So we're kind of seeing that scenario 1 and scenario 2 phase happening here. Scenario 1 is where they rotate around a common axis, and scenario 2 is where they kind of merge together. Now, the merging is a little ugly with this one because Humberto is really struggling to maintain his strength. It's not doing well. And then you essentially have Imelda just absorbing whatever energy is left with Humberto. So that system's weakening pretty quickly in Humberto, and that's why you're seeing Imelda kind of take in whatever energy is left of that storm. So it's kind of funny the way you look at this graphic right now. I'll take it full screen for you. It's kind of like a little game of Pac-Man happening right now in the Atlantic is the way I'd describe it. Essentially, you've got Pac-Man's Imelda's getting ready to eat one of the little things there out ahead of it, one of the little dots, and Humberto's the storm that's kind of getting eaten up here in the Atlantic Ocean. So again, this has been a very, very tough forecast here, and we're going to talk about why not only this forecast was so hard, because I know there's a lot of different data that was put out with this forecast. There was some scary data put on social media about what Imelda could have brought to the Carolinas. And here in the Carolinas, we didn't get much at all. Now, along the coast, they did have some significant impacts, especially in Buxton, North Carolina, along the beach, where we had homes collapse due to those strong swells up on the coast. But here locally in the Queen City News viewing area and further inland, it was just scattered showers. So we went from, on the model data, 12 to 16 inches of rain to actually only receiving maybe a quarter of an inch in some areas. So I'm going to discuss why this forecast was so tricky. We'll also bring up a sound bite. So we talked with Dr. Matthew Easton about a week or two ago on Pinpoint Weather University, and he spoke about why tropical forecasting was so hard as well. We'll listen to what he had to say a couple weeks ago coming up here on the other side of the break here on Pinpoint Weather University. As I go to break, I do want to leave you with a little bit of video from those two storms tangoing, doing the tango a little bit, just dancing around each other out there in the Atlantic. Welcome back into Pinpoint Weather University. Thank you so much for keeping it with us here on Queen City News Plus. Also, our YouTube viewers as well. I'm meteorologist Brandon Lawson. We've been talking about the tropics so far for this episode, and very warranted because we had a tough forecast we had to deal with. And I want to talk about that forecast, but while you're here, I still want to talk about what else we have coming up here. So the tough Imelda forecast, that's the big thing coming up in this segment. But I also want to talk about the missing weather data in the Atlantic and how that can make forecasting challenging as well. First, let's start by talking about the tough Imelda forecast. Why was there so much uncertainty with this forecast? We've got all this technology. How could we not figure it out a week or so out? So let's discuss it here. I want to take it full screen for you. So this was the first model trend that we had with Imelda and Humberto. So models initially had Imelda being a slower moving storm to the north. And that was going to allow the cyclones to rotate around each other. And Humberto being the stronger storm, that was going to pull Imelda out to sea. So that was what the models initially said to us. And that's technically what ended up happening. But why did you see all those scary posts on social media about a foot of rain in Charlotte and a foot of rain in spots like Columbia and things like that? And even Charleston, we were seeing biblical numbers posted on social media with some of the model data. Why did we see that? Because what ended up happening, the models flipped on us. Later in the week, models said that Imelda was actually going to be faster to the north. It was going to move faster. So it was going to run out Humberto. It was going to run ahead of Humberto, and the storms weren't going to be close enough together to make that Fujiwara effect happen. So what ends up happening with that, Imelda is just going to move inland, and it's going to create all of that rain for us here in the Carolinas. That's what the models were saying later. So that's why the forecast got so tricky later in the week. And that's why you were starting to see a lot of scary things on the forecast. So yeah, why was there so much uncertainty? Of course, models flipped on us. And then models flipped again, but they flipped for the good, at least for better, for our region at least. So models later, what ended up happening, they caught on, right? And they said, you know what, there's going to be a high pressure system that parts itself north, really over the Midwest, the Northeast, and there was going to be a little cutoff low, and I'll show you kind of what that looks like in a second, but an area of low pressure off the Southeast. So what ended up happening is that Imelda stalled offshore. So the models are like, there's going to be nowhere for Imelda to go because it's going to be blocked by these two systems along the eastern U.S. So Imelda stalls. That's what the models were saying. Imelda's going to stall, and that's going to allow Humberto to catch up to Imelda. And once that catching up happens, Imelda is going to get pulled back out to sea. That is what ended up happening, folks. That's what happened. Imelda stalled. It couldn't move inland. It was still had a fast track. Imelda was still moving pretty fast, but it couldn't go anywhere else once it got close to the coastline. It didn't really even get close to the Carolinas coastline. It kind of got stopped in its tracks before even getting close. And then Humberto caught up and said, "Come here. Let me bring you back. Let's get you away from there." So that's what ended up happening. And that's how all that transpired. So that's why there was so much uncertainty. Unfortunately, though, I do want to caution you when it comes down to weather, watching. Make sure you follow reliable sources. Us here in the Pinpoint Weather Center, Chief Meteorologist Tara Lane, myself, Meteorologist Andrew Brightman, Meteorologist Ted Faden, we're always going to give you accurate information. We're never going to scare you, especially 1 year after Helene. We know there's a lot of stress when it comes down to tropical systems right now, especially with some of the hardship that our friends in the Western Carolinas are still going through. So we're always going to keep it real with you, and we'll always let you know as soon as we have a better idea of the forecast when things might be coming. So why did Imelda stall? So essentially we have this high pressure center in the Atlantic called the Bermuda High. It's what steers hurricanes. However, when it's a stronger Bermuda High, it allows tropical systems to get closer to land. But what happened in this scenario? So we had Imelda, right? And we also have Humberto. I took Humberto off of this just to kind of help us out a little bit. So this is Imelda. It formed right around the Caribbean. And then notice there's that high pressure center that is parked over the Midwest. And then you've got an area of low pressure that's parked over the Southeast. We actually call this a Rex blocking pattern in meteorology. The reason we call it that is because there was a guy by the name, I believe it was Daniel Rex, back in the 1950s, 1940s. Don't quote me on that, but I do know the last name was Rex. And he created this pattern. He said that anytime there's a high parked over a low in the upper levels, that means we've got a blocking pattern taking place. And when that blocking pattern happens, nothing can really move through it. So Imelda pretty much had to stop because it didn't have anything guiding it onto the coast and into the Carolinas. So that really, really spared us from what could have been a very scary situation for us because we had this Rex blocking pattern in formation over the eastern U.S., and that really kept storms away from our region. So that is some really good news there. Now, tropical forecasting could be really, really hard. It's a difficult forecast. You're probably wondering, Brandon, we've got all this technology. We've got all these models. We've got all this research. Why a week out are we still kind of confused about tropical systems? Why is it so hard? Well, I talked with Dr. Matthew Easton, who is the professor of meteorology at UNC Charlotte, here on our episode of Pinpoint Weather University a couple weeks ago. And he spoke with me about the peak of hurricane season, why it was slow, and if he thought things would pick back up. And he said things would. Obviously, that came true, that prediction. But he also spoke with me about why long-range forecasting with hurricanes is still so hard. Even with all the technology we have, there is a void of some things in the Atlantic. Take a listen to this.
It's a challenge for the weather models to really make long-term forecasts, mainly because they come off of Africa, where there's a decent amount of weather observations. But once they enter the Atlantic, it's largely a data void region. Because the models rely on surface weather observations, weather balloons that are sent up, as well as radar, but all three of those are missing in the middle of the Atlantic. There are satellite observations, which are helpful, but you really need the combination of multiple observing systems to get the information. So it's a little bit of a data void, and as the waves then work their way over toward the Caribbean, that's where those first kind of weather balloons come from with the islands And then in fairness, you can also get the Hurricane Hunter aircraft that can make it into it at that point too. The aircraft can't fly all the way across the Atlantic.
So just kind of breathing a little bit and taking all that in. So essentially, Dr. Easton, he spoke with me about the forecasting challenges. And when hurricanes are in the middle of the Atlantic, or especially far off, these hurricane hunters, who do an incredible job, by the way, and I believe with the partial government shutdown, they'll still be doing their job during hurricane season because it's essential. It is essential to keep us safe, essential to life and property that they get out there. So that's why you've got those guys at National Weather Service, National Hurricane Center that are continuing to work. But I can't remember exactly which storm this was, but I want you to look at the stadium eye so you can kind of see how all the air is just sinking in the eye of this hurricane. And as that air sinks, it spreads out. Satellite data doesn't always give you a perfect image like this, especially when storms are way out there. So these hurricane hunters, they're inside the storm. They're getting weather data. They're getting wind data as well. It's just helping them kind of observe what's happening with that hurricane, because out in the middle of the Atlantic, we don't have anything to collect weather. Here in the U.S., we've got all kinds of different ways of getting weather. Airplanes, they give us weather data that weather models can use to figure out what's going on. Also, our weather stations. We do weather balloon launches every morning and every night at pretty much all National Weather Service offices across the country. Those weather balloons, they launch up and they give us an idea of what's happening in the upper levels. I always tell folks, whatever's happening in the upper levels is what happens down at the lower levels, because the air there is what transforms all the weather and moves all the weather around across the country and really across the globe, jet streams and ridges and different things like that. So those weather balloons are important because they can give us a current look at what's happening at the ground, but also a current look at what's happening in the upper levels. So if weather models know what's happening right now, it makes it easier for them to predict what's happening in the future. So when those storms were out there towards the Caribbean and just north of the Caribbean islands, there wasn't any weather balloon data. There wasn't really any current data. Hurricane hunters weren't out there yet. So it was just a lot of just voided data that we did not have. And the weather models could not hold on to what could potentially happen in the future. So again, models need to know what's happening now, and it gives them a better idea of what's going to be happening for the future when it comes down to hurricanes. That's really for all weather situations. Where's a cold front now? Where could it be? So that's why it was so tricky and why the forecast kept going back and forth. Sitting now later in the week when the hurricane hunters were out there, they were doing their recons, giving us an idea what's happening with the storms, flying through some of the atmosphere in the upper levels. Models were able to catch on like that. And we were able to, during that weekend, we were able to forecast pretty much a perfect forecast on what was going to happen. And the trends, the models were also catching on to the trends too. Rain totals just gradually coming down as we got more data out there. So that's why tropical forecasting can be hard. And it can also be hard in the winter too. You see winter forecasts a week or so out where there's a lot of misinformation, a lot of communicating of just big time snow numbers. But there's something in meteorology, unfortunately, it's called wish casting. I think people get excited about this stuff and they just post and get really excited about it. And unfortunately, some of that stuff is just not true. We got a little bit of time left. Let's get a quick break in. We'll talk about what we can expect from the tropics here on the other side as we go through the next week or so. Welcome back into Pinpoint Weather University. You're getting a look at water temperatures here on Wednesday, October 1st. I want you to notice a little bit cooler of the sea surface temperatures as you're getting a little bit further north. You got 84-degree water temperatures as you get further south there, and then 82-degree water temperatures as you get further north. I believe Imelda and Humberto have upwelled a lot of cooler waters there in the western Atlantic. Could help us in the future. We'll see how that goes. Tropical outlook through Wednesday, October 8th. Luckily, we're not expecting any tropical activity, any tropical systems, at least for now, but that could change. I'm meteorologist Brant Lawson here on Pinpoint Weather University for Queen City News Plus. Thank you so much for joining us on the show today. Again, if you're just catching up with us, National Weather Service going to be operating as normal for now during the partial government shutdown. That could change. Tropical weather data, it's hard to forecast, but we'll always forecast as hard as we can for you guys at home. I'm meteorologist Brant Lawson here on Queen City News Plus for Pinpoint Weather University. Take care of yourself. Take care of each other. Continue to communicate together. weather and climate as much as you can.
Queen City News Plus. Just search Queen City News on your smart TV's app store.